So first of all, what is data engineering? I would love to get your input on this as well. So if you know what data engineering is, feel free to chime in. Or, even if you don't work as a data engineer right now, you must have maybe worked with a data engineer in your company. So tell us about it. Any comment? Raj said gathering and cleaning data for sure. That's always part of, I think this is part of the responsibility of data engineers, but data scientists and data analysts need to clean data as well. Gathering data for sure. We will be talking about data ingestion today. I have some diagram I can show you guys. I plan to do a live, demo and just do the diagramming on the fly. But then I just realized that I don't think we have enough time today. But I'm going to show you a diagram I created earlier to help you understand end-to-end data flow, workflow. Database administration and governance. I would say database administration, that's interesting. So that's probably what DBAs would do. But when things move to the cloud, it becomes a little bit different because, if your company use, Redshift or Snowflake databases, these are, or data warehouses, right? Tech engines. And these are managed services. So there's actually not a lot you need to do on the administration side. But I think data engineers will probably be more involved in, tuning queries and processing data, writing, data pipelines. Definitely a lot of SQL will be involved. But some companies may use Apache Spark and some other tools like Hadoop, but they all have like a SQL flavor. So you can use Spark SQL as well. Governance is a big part. Data engineers are definitely involved in data governance, but usually, in different companies, they have a separate data governance team under IT. But part of data governance is actually data, encryption, security, and data quality as well. So yeah, data quality is definitely part of governance, and that's something data engineers work on as well. Eugene said, building pipelines to ingest data, absolutely, and processing data to make it easy to query for downstream users like data scientists. Yeah, I think this is a big part of data engineers' job, preparing data for data analytics in general. I think data scientists and data analysts or BI specialists sometimes need to roll up their sleeves and just work with raw data as well. But when you want to automate the workflow, it's usually data engineers' job. Performing ETL operations in various platforms according to business requirement. Yeah, absolutely. Well, you guys know a lot about data engineering already. So let me explain data engineering. We start to see the convergence of engineering disciplines. I think if we look at data engineering, right, data science, software engineering, DevOps engineering, the skill sets are, they're overlaps, right? But even though the job role is very different, right? I would say data engineers and data scientists may have more overlap, right? In terms of, the toolbox, right? What kind of tools and stack they use. For example, both data engineers and data scientists will need to know SQL, right? That's a must-have. Python programming, ideally, but some data engineers work with Scala and Java as well. Data scientists might be using R, but Python right now is pretty popular. And they both need to know some sort of data pipelining tools, right? Automation as well. Data engineers will definitely work more on the automation side. And between data engineers and DevOps engineers, there's not a huge overlap. But I think in the past, right, when we write ETL and SQL, a lot of big organizations rely on commercial tools, right, for ETL. So they don't really necessarily adopt, GitHub, CI/CD, right? A lot of the continuous testing stuff. But we start to see data engineering organizations start to adopt CI/CD as well, right? Because you need to version control your data engineering, like, Airflow pipelines, for example, and all the data transformation functions, you want to test that as well, right? And as part of the ML ops, right, machine learning operations, and sometimes data engineers, work on those end-to-end pipelines as well. Your function, maybe it's bug-free, it works. However, sometimes, the data input has issues. So you not only need to version control and test your functions, right, and code, sometimes you need to test the quality of the data as well. And then you need to do the data version control as well, right? So, and both data engineering and DevOps engineering will build infrastructure as well. Data engineers are not platform engineers, but in some cases they need to, still, especially when you work for startups, like data engineers will need to launch EMR clusters, right? And sometimes they need to work with Docker and Kubernetes as well, because maybe their Airflow pipelines are running on Kubernetes infrastructure. Data engineers on the data ingestion side, sometimes after you write some Python code, you want to deploy that. Maybe you can use Amazon Lambda, AWS Lambda functions, right? Instead of using a virtual machine or an EC2 instance, the cost might be high. So data engineers need to know a little bit of, cloud and infrastructure as well, and CI/CD. And software engineer, and of course, data engineers will need to write code. I think the similarity between data engineer and software engineer is that they need to write good code, right? But data engineers usually don't build web applications or software. That's, a little bit different. What are the responsibilities and requirements or required skills for data engineers? Let me answer this question. So this is a diagram that shows you, where data come from and where data go, right? Companies need data, for analytics and insight that's serving the business units. But a lot of companies will want to leverage, right, the outcome of analytics and AI, right, for their applications. So on the right-hand side in that green box, you'll see, well, usually data comes from the bottom, right? Source data. But the output of that pipeline is probably some sort of decision making, because, there's dashboard, right, that supports, business insight, or maybe the data prepared, by data analysts can be, or campaign analysts used for marketing campaigns, right? On the left-hand side, we'll see machine learning models deployed in production, used, by web and mobile applications as an endpoint, for example, right? But a lot of these actually depend on data. So we're not really talking about data used in production, right? The production systems usually generate data, and data will need to be ingested somewhere. So we'll explain that today. But imagine you have, like, a lot of source data. Some companies will deal with like more than 50 different data sources and even more, right? I think an average, organization should at least have like, 15, 20 different data sources. And we would like to centralize the data, right? So the data will need to be, ingested somewhere. We'll talk about data lake and data warehouses later. But, usually when the data gets ingested, it's the raw data. And you probably want to keep a copy of those raw data, right? In the past, the cost of storage is high. Companies will need to purge data, from time to time. But now I think with, data lake, storage is pretty cheap, right? So you're going to dump the data into data lake or data lake house. And then data engineers will still need to figure out how to process those data, because imagine you're dealing with 100 different data sources and thousands of tables. After you put them into Amazon S3, still that's like thousands of folders and millions of, objects maybe. So data engineers wanted to write code to do data extraction, right? And then pre-process the data. This is usually where ETL happens. ETL, it stands for extract, transform, and load, right? But we'll talk about ELT today as well. And then data, get massaged and transformed and get turned into something called analytics data, right? There might be many different versions of these data for different departments, right? Different teams. These data are now, is now ready for data analytics. So data analysts might be using, these data for building reports, right? Ad hoc reports or building dashboards for business consumption. And the data scientists will be building machine learning models, right? After the model has been trained, they probably do a lot of experimentation. And a common approach to deploy the model is just to do the batch prediction. And let's say we're predicting high-risk customers. So on the business side, they probably want to know who will become high-risk customers in the next 3 months. So it doesn't really require any real-time, decision making, unlike, let's say, fraud detection or credit scoring, right? So that data, you can just get a batch file, a list of like customers, and then apply the model and generate the prediction. That's super straightforward. If your company has really massive amounts of data, then you can use Apache Spark, Spark ML, or use a user-defined function to generate the prediction, right? But I think the most useful application of machine learning is definitely application in real time. That means the data scientists will need to know how to package the data and deploy the data, right, as an endpoint. So that touches on infrastructure a little bit as well. So what's the best way to package and deploy your model, right? And then what's the serving infrastructure? And once the model is, is live, how do we monitor the performance? Because sometimes companies care about the latency and the scalability, of your prediction engine, but the data scientists or ML engineers probably also care about, is my model still valid, every day, right? So that means we need to validate the data as well, or the predictions generated, in the live system. We need to make sure that always making sense. So you have to closely monitor those. So this is the general, I guess, the flow here. Well, that involves many different kind of data professionals, right? Different roles. And in the yellow box here, you'll see data engineers, right? Data engineers will source data, ingest data, process the data, right? Do ETL, ELT, and create data that can be used by the entire organization. But I think data engineer's job is not just limited to that. That's the traditional definition. I think, the modern data engineers actually do quite a lot of different things as well. Sometimes data engineers are involved in, automating or automation of machine learning pipeline. Well, in some companies, it might be the ML engineer. So in some way, there's some resemblance there. In the green box here, we see data scientists, right? They'll be working with analytics data, generate machine learning features. They focus primarily on, insight discovery and also building advanced machine learning and deep learning solutions, right? And they will do batch predictions as well. But a lot of times what data scientists work on are experiments, right? Experimentation. When we're talking about production deployment, that usually is machine learning engineer's job, or in some companies, software engineer, right? So that means you need to build some sort of, endpoints. And that's what ML engineers do. ML engineers, ML ops, they will handle large-scale model training, model automation, monitoring and production, and of course, deployment. So the purple box here is ML engineer. Okay, so hopefully that helps you understand, the similarities and difference, among different data, or different data roles. Now, I'd like to help everyone understand that there are also different kinds of data engineers, right? Not all data engineers will be the same. They do different things. Like in some companies, the data engineers are primarily doing ETL, right? Or ELT, data integration, transformation. So these are the traditional data engineers. There are a lot of them, and they're very important, right? In a traditional sense, like data engineers, or these ETL specialists, they might be working with tools like IBM Datadog, right? Microsoft SSIS, those kind of tools. But the startups are not going to use these tools. Like the exciting startups, they're just going with open source and cloud, right? And that's why we see, banks moving to the cloud, right? GCP, AWS, and we sometimes do, corporate training. We train banks on adopting AWS, and they're trying to, even adopt like serverless ETL stuff using Amazon Lambda, and serverless Apache Spark and things like that, like Glue, right? Azure also has pretty nice, infrastructure and managed services for data engineering, such as Azure Data Factory, Synapse Analytics. But yeah, ETL, ELT. If you come from a data warehouse or ETL background, I think just switching to data engineering is not hard. I think what you do is already data engineering. But it's just like whenever the industry has some new trend, they like to create new names, right? So it's like data scientist. But before data scientist, statistician, they're data miners. A lot of people do machine learning already, right? So I think this is probably a big portion of the jobs out there for data engineers are still ETL, ELT related. And on the ELT side, and there's a new title that's getting pretty trendy, which is analytics engineer. To me, this is data engineers writing SQL, working with data warehouses, and doing data modeling, and working with DBT. And for some reason, this is called the modern data stack. And I think these names are driven by vendors. But it's cool. Like it shows you how important and how popular data engineering is nowadays. The second type of data engineers, the job title may not be data engineer, right? But these are the software engineers who work with data, right? Maybe they're writing applications and their applications will need to constantly talk to databases. So they might not be working with relational database. They might be working with Cassandra, MongoDB, NoSQL databases. Their applications might be streaming data to Kafka, for example, right? And they might be even building some, data infrastructures in-house, like what those big tech does. Well, to me, this is one type of data engineers. And we have the BI or data engineer that focus more on, just building the data sets, right, for business intelligence and for data science. This is a very important role as well. And the BI data engineers sometimes we need to work with visualization as well. So, the ETL, ELT engineers, they do data modeling and ingest data, integrate data, right, create the, but the BI data engineers sometimes will work on the consumption side, right? They will still need to write a lot of queries and automate it, and help the companies to build dashboard. But they don't necessarily are the person who are building the dashboard. They definitely work with the BI analyst. This is another type of data engineer. And there's also the ML data engineers and platform related data engineers. There are lots of different kind of data engineers. Here I'm mentioning the ML data engineers because when I talk to many different startups, and sometimes they have machine learning engineers, but after talking to them, I realized that, yeah, they wear multiple hats and they work with Airflow, automate data pipelines and prepare data for data scientists. And they also automate the ML workflows. And these are data engineers as well, but they can get categorized into ML engineers as well, I guess. So I think data engineers, modern data engineers can be very versatile and they can work on many different things as long as they have strong programming background, they know databases well, and if they know a little bit of machine learning as well, they can do many different things. That's pretty cool, I think. So what are some of the latest trends in data engineering? I listed 3 to 4 of them, and hopefully, hopefully that's helpful. So first of all, I think one really good opportunity for someone who want to work in data engineering is just the data migration, migration to the cloud. Whether you want to launch your own consulting company or there's a ton of jobs out there just related to data migration. But it's not really just migrating the data. I mean, that touches the entire infrastructure, right? So there are a lot of contracting jobs out there. It might not be permanent. Companies has like a 1 year, 2 year plan to migrate everything from on-premise to the cloud. And if you specialize in cloud data engineering, you're familiar with databases, there are a ton of opportunities there, right? And your past experience, working with on-prem systems, right, will be very important here. Because if you work with like someone who only only knows modern data engineering stack, they might not be the best fit for this type of roles. And it definitely will need to have some kind of enterprise IT experience as well. But in this case, for example, if company has Oracle database and SaaS servers, SaaS is one of the vendors for data analytics, but they have ETL tools like SaaS Studio as well, right? But now they have the cloud version called SaaS Via, which is pretty powerful actually. So so companies will be migrating all of their data, right, from SaaS servers to the cloud. But I mean, most of the time the vendors have solutions already, and it depends on the cloud your company choose, right? If you work with AWS, AWS has schema migration tool. It has the data migration studio, so it can help you easily migrate data from on-prem to the cloud. And of course, you care about security, data transfer. And if you have like really massive amounts of data, AWS also has all kinds of solutions like Snowball and Snowtruck and things like that. But it's not really just copying your data into the cloud, right? But it's also a little bit data architect, like how do we structure the data in Amazon S3? What kind of databases are we going with? So it's actually a lot of work there. And securities, landing zones. So that's one trend, but this is not the new trend though. The modern data stack has been around for a couple of years. This is the real trend here, right? I think in the data engineering world right now, there are two to three different schools of thought. There are the people who on the Spark side who believe in data lake, right? And lake house. But there are also, there's the vendor-driven, I would say, modern data stack that focuses more on the, automation, automated solution, I would say. It's pretty cool technology. For example, the example I'm going to give you here is Fivetran for data, for data ingestion and connect. So basically, it's just a bunch of data connectors, right? And data warehouse, let's say Snowflake, which is cloud agnostic, right? DBT for automation, workflow, and all the transformation stuff, and high touch or some, similar tool for reverse ETL. So, if you read Reddit, there's some very interesting debate all the time, right? Some people think it's just a hype, and some people think it's the real deal. And I think it really depends on the company you work for and which stage, right, of their data engineer maturity they're at. Sometimes you see companies using modern data stack moving to data lake, but the reason why this is attractive is because I think a lot of the small to medium sized businesses, let's say they have they at the very beginning of the life of the journey of this company, they focus on building applications. They use whatever tool they have, right? Open source, PostgreSQL. And they built the core application. They start to have users. And at a certain point, they realize that, well, we got to have a data warehouse. We start to have more and more users, right? More and more data sources. Because in the past, the only data they have is the application data. And then they start to have user data. And then the company itself start to have CRM systems. They have to start to have, ERP system. And they work with HubSpot, right? Different kind of vendors. And they want to collect those data, right? And Fivetran comes in handy because it basically has connectors to 120, 100, 200 different kind of SaaS tools, right? So let's say for sales data, some companies, let's say WeCloudData actually use HubSpot. A lot of companies use Salesforce. And HubSpot itself has a pretty complicated ER diagram. They have like a ton of tables, right? But if you want to get all of the contact, lead, right, those kind of CRM data into your own data warehouse, the first thing you need to figure out is well, how do we ingest this data into our own data lake, right? Even when I talk to our sales, I say, well, we're going to ingest some data and build dashboard. And the sales will question that and say, okay, I have everything in HubSpot. Why should we build another version of it? Like, I just want to keep everything in my HubSpot. That's the tool they love, right? However, that's not going to be a problem if the only data they use is in HubSpot. However, over time, then you want to integrate data from different sources. That's the whole point of data warehouse, right? Let's say you want to collect Zoom data, you want to collect SurveyMonkey data. And when your marketing team does marketing campaigns, they may not be using HubSpot. They might be using MailChimp. Now you may want to, combine these data, right? You may want to know, well, this sales lead or this potential customer, you not only want to know that, well, you had 2 email exchanges with them, we caught them 3 times, they picked up once. You also want to know, well, the marketing sent them actually regular emails, they never open your emails. Maybe that's not a really strong intention in that case, right? It's just like when you guys come to, the meetup sessions, it doesn't mean you're always interested in our courses, right? So data integration becomes very important because we want to know more, right, about the potential customers, or, but it's not just about sales, but there are a ton of different data sources, right? So Fivetran has connectors. So instead of writing your code, because HubSpot, Salesforce, they all have APIs, and but like writing your custom code, it's great, but you have to keep up. So the maintenance cost is very high, and it's definitely not fun. Like in some companies, the data engineers will have to write code to work with different APIs. And finally, when these companies start to realize that, oh, there's tools like Fivetran, it's not cheap. However, and when you do the math, like, do we need to keep one senior data engineers that cost $200,000 a year, or do we pay $50,000 to Fivetran and then they ingest all of your data automatically? And they just like need to do some configuration. You can have a junior data engineer, or maybe, right? And that's why like tools like Fivetran, right, become really popular. These are commercial tools, and there's also the segment for collecting, third-party, first-party data on your website, web analytics. An open source version is Airbyte, which is becoming pretty popular lately. We cover Airbyte and let students work on projects as well. I like the tool; it's pretty promising. They got a lot of funding as well. But these are the connectors that help you ingest data into, well, the data lake. And traditionally, if we're talking about telecom, banks, they have ETL infrastructure, which means they do data transformation. They will into data first, right? And then transform the data and then load the data into warehouse. But the modern data stack, guys, it's mainly centered around Snowflake, right? And they think that, well, the data warehouse can do everything. Like, let's just dump the data into the warehouse. Let's skip the data lake. All right. So that becomes the ELT. So extracting data through those connectors like Fivetran and load the data into warehouse directly in staging area, right? And then you can use DBT to write all kinds of transformation code, but it's still SQL, right? And then all the transformation happens in data warehouse. And then you have your production version of the warehouse and data marts. They don't even believe in data marts now. They believe in building a very wide, flattened table. That's kind of interesting trend. But DBT is sort of the enabler of that, right? It's pretty cool, honestly. But after the data warehouse has been created, right, you centralize all of your enterprise data in the data warehouse, but the job doesn't stop there for a data engineer, because ultimately the businesses will want to use that data, and you can't expect the business people to be all like SQL users. Some of the clients, the real client projects we do, they have a lot of business users, but like very few of them are comfortable with writing their own queries. And sometimes, to be honest, you don't even trust them. Like, the queries they run, like, is that number correct? So but the business will want the data to be sent back to HubSpot, for example. Let's say your data scientist, created some predictive models, right, based on the data they extract from Snowflake. Now, that machine learning model had generated some prediction, let's say predicting the customer lifetime value and predicting the risk of the customer. Well, that data is in your warehouse, in your data science, workbench. It's not in HubSpot because you want the sales to know. And then so the sales can do prioritization and say, oh, this customer has like, 100,000 lifetime value, pretty high. But this is also a high risk customer. And then they're going to treat that customer differently and prioritize the resource and time on those customers, like the big clients, right? But you need that data to be available in HubSpot just in time before the communication, right? So that means the data needs to be somehow like, the data is extracted from HubSpot, right? Sent to the warehouse, and then you do some sort of enrichment. That's the integration process, because now you have data integrated from 50 different sources. You want to send it back to HubSpot. You can work with the API, but there are connectors, but they are, on the warehouse to the SaaS platform side, that's called a reverse ETL, right? So you're sending data from the warehouse out to the SaaS systems, like, for companies who want to do Google ads, Facebook ads, they want those data, customer profile data, to be sent back to those systems, those platforms. And there's open source project. Well, High Touch is not open source, but there's some pretty interesting tools out there. So this is the modern data stack. It's centered around SQL and data warehouses. And some people may argue and challenge that storing all of your big data in the Snowflake, the cost is really high, even though storage and compute, right, are separated. I personally think it's really cool, but I'm not a huge fan of it. It really depends on your use case, especially when you have a lot of unstructured data. Snowflake might not be the best option, but they keep surprising people, like doing really well. And seems like they're even going to support Python and machine learning in the future, but I think it's going to take many years. But yeah, it's an interesting trend. A lot of analytics engineering jobs in this field. If you come from traditional data warehousing background, you should definitely adopt, modern data stack. That will help you with your transition for sure. Next trend, data lake and data lakehouse. Right? Data lake has been around for a while now, and it all started from Hadoop, right? Hive, Apache Pig, and then later on Apache Spark got open sourced around 20, is it 13 and 14-ish, right? And Spark has been around for a while now. But the traditional data lake has sort of proven to be inefficient, right? A lot of companies data lake, but it has some challenges, security, right? Catalogs, it's just when you have a lot of data files in Apache Hive, for example, the performance is not great. And finding data is also a challenge. Data cataloging, and it doesn't support ACID, right? Which means, deleting data is not that straightforward. And if your company needs to, for GDPR reason, right? Because data privacy, sometimes the customer can request the company to delete all of their data. But then a customer's data might be all over the places, in a ton of different tables or data sets. So every time you want to delete something, there's writing a massive Spark job that takes like 30 minutes, half an hour to run just to delete someone's data. The cost is really high. And that's why data lakehouse started to become more and more popular, because it supports, right? Lakehouse is a table format, right? The popular ones include Apache Iceberg by Netflix. There's the Delta Lake, and there's the Databricks version, but also now the open source version, Apache Hudi, which is used more at Uber. These are all great table formats that are getting more and more popular. So deleting data, right, ingesting that, making changes to data now become a lot easier. When you do the comparison, and this is from someone's blog post, a great summary. Data lake and data lakehouse, right? I think the advantage is that definitely still storing data in object store or blob storage will still be cheap. You can't expect to implement like Snowflake, right? For the entire data, like data your company has at Uber, and the cost is just, too prohibitive. It's impossible. It's too expensive, and they have to work with like data lake, right? And then they will do the ETL stuff to build a data warehouse, so that means they can still use Snowflake, but just not ingesting all of your raw data. But this makes total sense for a smaller company that just don't want, maybe the company is not specialized in data engineering, and they for them, like just paying the premium fees to those vendors makes sense for them, right? And those are open source table formats. It supports any kind of data type. I think that's the advantage of data lake, right? But Google originally invented or worked on MapReduce and the Google file system, and then turned it into HDFS, the Hadoop file system. Well, it was created for storing unstructured data originally, or the text data, right? So I think that's still the advantage of data lake. You can still make it work in Snowflake. They added a lot of capability, but still it doesn't feel natural. These are still databases, and it deals with structured data, right? But whenever you have a database, right, the integrity, quality, performance, well, it says it's high here, but I've worked with many databases that has really poor data quality. It really depends on who's using it, but just by nature, I think data lake does lack, a lot of these, integrity, performance. Working with data lake, it doesn't like data lake is never fast. But now with Presto or TrinoDB, there's some really cool technologies that make your queries run really fast. But in general, it's more scalable, right? But the performance compared to data warehouse or just a regular database engine is definitely slow because the data is not really indexed, right? But it's more scalable. If you're into data lakehouse, well, there's 3 platforms or open source projects that are popular right now: Delta Lake, Apache Hudi, and Iceberg. Right? They're all trending really well. These are just based on the star history on GitHub. The next trend, serverless data engineering. Serverless is everywhere. It's not necessarily like for data engineering, right? But interestingly, start to hear more companies using like Lambda functions, for example, and to do data engineering. Because when you think about data engineering, it has data ingestion. So some of the data ingestion can actually be done using Amazon Lambda functions, right? Unless the data comes in like at really fast speed and really large volume, then you probably need to use Kinesis or Apache Kafka for streaming data analysis. But when you want to do data transformation, serverless can be leveraged. It feels like it's very cheap at the beginning, but you have to decide, because when you have huge volumes of data coming in, using Lambda, the cost might be actually really high. So it depends on your application. Glue is the serverless Spark service managed by AWS. So that means traditionally companies will need to launch a Hadoop cluster or Spark cluster. In Amazon, then that's Elastic MapReduce, or Netflix will probably build their own. And you can run Spark on Kubernetes as well, but you need infrastructure, and you probably need to run that 24/7, right? Because traditionally the big data is stored in HDFS. That's a special like distributed file system, and it runs like you can't store that on Amazon S3. You have to store that on in EC2 instances or running on a Spark cluster. So the cost is actually quite high running a Spark and Hadoop cluster. And Glue is consuming data from S3. So all of your raw data will be stored in object store, which is super cheap compared to the databases and and Hadoop clusters. And whenever you want to process the data, let's say you have a data pipeline that process some raw data, do some transformation, and load the data into a NoSQL database. And let's say that ETL pipeline takes 1 hour. So You just need to pay for that 1 hour of runtime, right? With Glue, it basically will launch, it's like launching a Spark cluster on the fly and reads the data from S3, process the data using Spark, and then it stores the data somewhere. You can store the data back into a data lake in S3, and then it will terminate the resource. So you just need to pay for that 1 hour of runtime. You don't have to pay 24/7, let's say, because a lot of times when you have a cluster running, you may not be running jobs. So it pays off for companies like Uber because the probably has like tens of thousands of pipelines. It's always busy, right? But it's not the case for a lot of companies. So serverless makes sense. But the diagram sometimes can look like very ugly because you have many services talking to each other. So sometimes debugging can be pretty challenging as well. So that's another trend. All right. So we talked about data engineers, different type of roles. We talked about what data engineers do, and we talked about the trend. Now, I'd like to help everyone understand the data engineering job market. What does it look like? First of all, I think data engineering jobs in great demand, definitely right now. If you search on LinkedIn and on Indeed, sometimes there are more data engineering jobs than data scientist jobs, but both are trending really well. And the compensation is pretty competitive. And I'll show you some numbers. And it's evolving really fast. So if you enjoy always learning new things, and data engineering might be for you, because some people will tell me like working as I used to be a data scientist and I did a lot of data engineering stuff myself. Working as a data scientist, the tools data scientists use are actually pretty much the same. Like, so there's machine learning, right? Algorithms, let's say the most commonly used 5, XGBoost, random forest, neural network, right? It doesn't mean you always need, like, there are hundreds of machine learning algorithms out there. A lot of them are pretty obsolete. You don't need them anymore. And for a specific problem, we might want to do some research and adopt a new algorithm. But most of those, you just need a few of those powerful algorithms, and that solves 95% of the problems already, right? And let's say the transformers and stuff in deep learning, we are not going to write those transformers because training those models takes a lot of time and a lot of computing resources as well. And we're really just doing transfer learning, leveraging those packages. So the business problems and data problems will change all the time, but the tools the data scientists work, it doesn't change very often, right? When it comes to data engineering, that's interesting. Change data infrastructure from time to time, and they move to the cloud. And when they hit the limit of Airflow, another open source project comes out, and you have to do some POCs, and maybe the company will adopt a new data engineering tool. So to me, that's quite exciting for some people too. So I think working as a data engineer, if you have that learning aptitude and curiosity, that might be the thing for you. And I think data engineers are usually, data scientist gets all the glory, right? Because they work more closely with the business and they're building AI stuff. Very, very exciting, glorious. But data engineers, I think, sometimes has really big impact, right? Because you help people eliminate repetitive work. Automation is very important. And building data pipelines, writing good tests, automate it. That's just like making sure the quality is good. That's really important. And I think data engineers make everyone else's work less painful and more productive. So I think data engineers are the heroes here. And of course, if you think about the future, with all the IoT, AI, but AI depends a lot on data, right? And IoT is going to generate a lot of time series data, a lot of interesting data, right? And Meta, like with all the virtual reality stuff, it's just going to generate more data, and we'll definitely need a data engineering, and of course data science as well. Let's talk about the job market. This is how the data, jobs are distributed in Canada, but this is really just a snapshot. So it changes over time. If I search next week, it's going to change. There might be more data scientist job again. So, and in Canada, I think majority of the data engineering jobs are in the three cities, right? Toronto, Vancouver, so Eastern time zone, West Coast, and Montreal as well. In the US, I forgot when I did this. And there were about 10,000 data engineering jobs out there. It might be 6,000 now. We have a little bit of recession right now, but yeah, there are a lot of data engineer jobs. Interestingly, machine learning engineering, right? The demand is going to be smaller than data engineering, but I would say ML engineers get paid a lot more, especially in the big tech, because that's sort of like the next step for data scientists. And most of the data scientists are not going to become machine learning engineers because maybe the engineering and ML ops side is not their interest and passion at all. They're focused on analytics and machine learning, right? But ML engineers need to wear multiple hats as well. Even though the number of jobs, right, is lower, but if you think about this, like relatively, like the demand, like companies, it's even harder to find qualified machine learning engineers. And in the US, at that time, like of the data scraping, looks like California, Virginia, Texas, New York, and then New York City seems to have most of, most data engineer jobs. But if we do the search today, it might be a different story. In terms of salary and job roles, in Canada, junior data engineers, this data is from Glassdoor. So it's around 85,000 for a junior data engineer, Canadian dollar. But the actual market rate right now is actually higher because Glassdoor data is always, it includes historical data. So it doesn't tell you the most current, the state of the job market, right? So I think it's around 100,000 for a junior data engineer in Canada. It's, compared to like pre-COVID, it's pretty crazy. Like a new grad, 100,000. But the story is totally different in the US, of course. But this is a number in Canada. And for senior data engineers, it'll be around like 100,000. But again, I tend to go lower, right, with these average numbers because, we need to set a reasonable like expectations, right? Because if you have more experience in software engineers, turning data engineer, of course, you can earn a lot more. But this kind of discussion or workshop is usually for someone who want to get into data engineering. So we're mainly talking about relatively junior positions. I think 100 is the reasonable expectation here. It's quite a bit different from in the US, right? These are base salary packages, not the total compensation. Right? When you do the total compensation, it can be a lot higher. But interestingly, you see senior data engineers in the US, it averages out to be 150, and it's even higher than data scientist, right? And higher than senior software engineer. But take it with a grain of salt because it really depends. If you're talking about Facebook, Meta or Netflix, it could be a very different story. But I believe these are the base salary, so not bad. It's actually pretty good. All right, so how do we become a data engineer? I'm going to show you WeCloudData's data engineering program curriculum because I believe, we designed this and tailor that to the job market. So I think this is one of the best, curriculum out there, but of course it's a challenging program. So first of all, I think you need to have the programming foundation. You need to know a little bit operating system as well, right? Linux, SQL, and Python. But in the program, I'm talking about like what kind of skills you need to learn, but in this actual boot camp, we sort of expect the student to have Linux, SQL, and Python experience already. Otherwise, it's going to be a little bit hard for you. But we usually have the pre-boot camp. The pre-boot camp are for someone just to absolutely pick up the basics, right? It's not for someone who already have advanced knowledges, okay? Scala, we made it optional. It used to be mandatory, but recently we noticed that, Python is probably just good enough because Scala used to be very important for Spark engineers, but nowadays PySpark and all the UDF stuff pretty good. So it depends on the company. Some companies will prefer data engineers to know Java and Scala, but in a lot of the companies and job postings, Python is actually more popular. So yeah, so that's why we focus on Python, but we cover Scala when we teach Apache Spark. Data engineers need to be familiar with cloud and infrastructure as well. They don't need to work like a DevOps engineer, so they don't need to have that much. It doesn't have to go very deep. I don't think data engineers need to be expert in, for example, infrastructure as code, but knowing a little bit, Terraform may be useful as well. But at least the data engineers will need to know how to work with data storage, launching EC2 instances, writing Lambda functions, right? Launching EMR Hadoop clusters. You don't need to like build a Hadoop cluster from scratch. No one does that anymore. But I think, the data engineers at least need to know how to work with these managed services, right? But in a boot camp, I don't think we have the time to cover all of these. So we focus on AWS and provide exercises for Google Cloud and Azure. And then comes the data warehouse, the modern data stack, right? So we cover Snowflake, a little bit AWS Redshift, since we teach AWS. There will be some labs. And then if we talk about data warehouse, then relational database, right? The internals of data relational databases, and of course, data modeling for warehouse, dimension modeling. Those are the data warehouse and the modern data stack stuff. So these are the things we cover in data warehouse. And of course, dbt will be covered as a workflow orchestration tool. And then we move on to big data. I think Hadoop is pretty old, but I think MapReduce and distributed computing, the concept is still useful. And then we focus on Apache Spark, and some of the labs are done using AWS Glue. And we cover NoSQL and Athena Presto, which is TrinoDB now. In AWS, it's Athena, but it's mainly SQL. So there's not much theory to teach there. So we'll just need to learn how to use it. And then we dive a little bit deeper into ELT and ETL, right? Data ingestion, working with Airbyte, Apache NiFi for ingestion. At this point, we don't really cover the change data capture yet, because that's what we cover in the second term. But there will be data integration, ETL with Spark SQL, and then Spark streaming to process streaming data. And after the big data and the ETL in Data Lake, we move on to Lakehouse. And currently, the curriculum focuses on Apache Hudi and a little bit Delta, but we're interested in exploring Iceberg as well. But I don't think it makes sense to teach everything. I think you just need to know one of these very well. So the second term capstone project, we have two capstone projects. The second term is actually on Apache Hudi. And we'll cover Lakehouse architecture, and the Kafka will need to be covered because that's part of the project, and Hudi uses Kafka as well. And then data pipelines, right? Automation, orchestration, Apache Airflow, and dbt. And then CI/CD, we cover Docker and Kubernetes as well. Kubernetes can be an option in the term one, in the term two project, running your Airflow pipelines. We cover a lot of Docker, but again, it's not a DevOps program, so we won't go very deep into Kubernetes. It's not necessary. On the data governance side, and of course, data quality, the high level idea of data governance, the people and process, those theory I think are necessary. There's also a data cataloging tool called Amundsen, which is pretty cool. We cover a little bit of that as well. But I think the founders of these tools from Lyft, now they are launching a commercial platform now. So I talked to them, but apparently it's not really like, it's not a, I think they're still building the tools right now. Project management. I think the goal of joining a bootcamp is ultimately still getting a job. So we have the option for students to work on real life projects. So we have the project management training to help sort of prepare the students for the live project, but student can opt out of that as well, of course. Okay, I don't think I'm going to go through all of these details, but this is really just one reference architecture for data lake. But we sort of touched on this already today. On the left-hand side, there's the on-premise infrastructure, different kind of data sources, right, from SaaS. But if you have data from Twitter, you might need to write some code to stream in the data and send that to Kafka or Kinesis. But again, so there's data coming from databases, data coming from your on-prem servers, data coming from your SaaS tools. So this is where you can actually use, you know, those data connectors, such as Fivetran or Stitch. But if you just want to focus on AWS, then you can use AppFlow. It's kind of similar to Azure Data Factory, where it has a lot of connectors. And data will be ingested into Data Lake. And typically, when data gets ingested into Data Lake, it's put into a bucket called landing zone, right? So these are the raw data, and very few people will have access to the raw data because raw data has probably very sensitive data, because the PII data, the healthcare related data. So typically, data will need to be transformed, and you need to mask and encrypt the data, remove some of the columns you don't want. In AWS, you can actually use Glue, which is serverless Spark, right, to do the masking, and then you send the data back to S3, and you call that the process data. You can have multiple layers in terms of the governance, right? But the raw data here, maybe only your ETL pipeline can access, right? But to process the data, you've already removed a lot of the, the sensitive and private data. So, more people can access that basically, right? And then the data scientists can leverage the data and use SageMaker, right, to train machine learning models. But yeah, this is a typical workflow in Amazon Web Services. Okay, so I think becoming a data engineer, we're seeing a lot of people going through data engineering training, and we find that typical mistake people make is like they just focus on learning the tools. But then in interviews, knowing tools is not enough. I think there are a lot of other things you need to learn. Data engineers sometimes need to know business as well, especially if you're the data engineers who work on data modeling and ingestion. So data ingestion means you don't necessarily, so first of all, you always need to deal with the business as well, right? Business has requests, and then to figure out what kind of data you want to ingest, right? And if you work with SaaS tool, that means if you work with Salesforce, you need to understand the Salesforce data model, right? Because when the data is ingested, when you're ingesting data, you need to pick what kind of tables you need, and eventually you want to do the data warehouse modeling, right, to build the star schema or whatever. You need to know how these tables are related. And when we're talking about CRM, that means data engineers will also need to understand how CRM works. Otherwise, even writing queries to join those tables can be confusing. So you need to understand the business rules, right? Understand data modeling and how to structure the data, right? Because you can use many different kind of data models, and some data models can help the queries run very efficiently. You can have pretty bad data models, it still works, but it's not great, right? And then to be able to write code, do automation, and understand infrastructure and tooling as well. So I think there are a lot of things you need to learn to become a data engineer. But a lot of times you can get trained and learn just on the job as well. Because when your team or your manager throw a problem at you, you sort of had to just figure out how to do things. That's the best way to learn data engineering, I would say. Or you join a more mature team, so they already have established, environment and pipelines. But that's pretty much it. So WeCloudData again has a data engineering bootcamp. If you're interested, you can scan the barcode, or you can go to WeCloudData website and find more details. I'd like to tell you a little bit more about this program before we end today's session, or before we start the Q&A session. So who is this program for? We designed this program for career switchers, people coming from traditional ETL background. If you would like to learn modern data stack and also Apache Spark and do more coding instead of just relying on the ETL tool, I think this is a good program for you. And maybe software developers who would like to work with data, right? And BI developers who would like to learn more technical, become more technical. New grads from computer science, if you would, because I think in the past, data scientists, everyone wants to become a data scientist, but I think data engineers are pretty cool. ML engineer is a little bit harder because it requires you to have data science knowledge and experience first, or maybe just focus on the ML ops side, but still not knowing machine learning is going to be tough. But data engineers could be quite, good for new grad as well. And newcomers, new immigrants, you may have experience in your home country already, but if you need a little bit local education and experience, this can be a good program for you as well. And we have actually quite a few data scientists in our data engineering program, because it seems to be a new trend. Like data scientists, they worked a few years, and some of them actually want to become more technical. I see data scientists switch into software engineering, but data engineering is also a good option, I would say, or ML engineers. All right, so again, just a quick intro to how we run boot camps, right? So the traditional boot camps compared to college programs and online courses, I think they have the portfolio building component, which is really good, and there's also career support. With WeCloudData, we run boot camps as well, so we help students build portfolio project. We also have industry mentors, so these are people who work as data engineers, right, in their daily, in their day jobs, and they will be able to give you more support and give you more insight when it comes to, writing resumes, and help giving you feedback on your portfolio project, as well as, helping you, when you're, getting interviews, they'll give you suggestions as well. And we do have the option for students to join real client project as well. I think this is, one of the killer features of our program, which is a lot of the career switchers. The biggest challenge, as I said at the beginning, is the experience gap. And the real client project can help you fill the experience gap. And again, this is the curriculum. I think we went through that already. And some of the projects. Oh, so if you go to YouTube and you can search WeCloudData, you will be able to find some student project demos. And this is one of the project. This is the term 2 capstone project. Some student built some really cool stuff. And this is a student who loves this game. And he came from no coding background 6 months ago. And he had a really hard time to work with C# to ingest the data. Unfortunately, that game doesn't support Python, right? But again, he ingested data into Amazon S3. He created a very simple, fast API, app that reads the file and put that into NiFi. So the data infrastructure here doesn't make 100% sense. And but that's a project that teaches students how to build things end to end, right? So it doesn't necessarily take cost into consideration, or is fast API and Python the best tool, right? But they sort of do this because they would like to create the data ingestion piece, right? So they're using NiFi to ingest the data, and NiFi is reading data from an API endpoint, right? And then they insert the data, ingest the data into a MySQL database. okay? But in real life, this is probably your real web application, right? And your web app already use a MySQL database. So you don't necessarily need to do this anymore, right? But they're really just trying to mimic this experience, and by applying a lot of the tools they have learned in the program. And then we have, again, MySQL database, right? So as new data gets ingested into MySQL database, and imagine that's the production database. You're not going to run queries on your production database. You can create a read replica, but it's not how ETL is done, right? Because you want to ingest the data into data lake. But if you do a truncate and load, that means every time you need to read the entire database and dump that into data lake. It's also not efficient. So one way to do this is just to set up the change data capture on your database end, right? So you need to have some agents running, right? Debezium is a really popular option. So we do cover that in the change data capture part, and that data gets streamed into the Kafka cluster. Again, this is the data engineering program. So students can run, Kafka in a Docker container, but in this case, the student used the Amazon managed, Kafka cluster. And then wrote some Scala code to process the streaming data using Spark Streaming. Now this is the Hudi piece, right? Writes data to Parquet, and then they use Athena for query and use Superset, which is an open source Tableau tool for visualization. So build a dashboard, and it's a real-time dashboard because the data just keeps coming in. Pretty cool. Copy this link and check out some of the project demos. All right, and then again, we have real client project that can help student fill the experience gap. And here's just one example, but I believe this is from a data science student. But yeah, this is a PhD student, graduate, coming from stats background. In the bootcamp, she created portfolio project, but it still looked quite weak, right? If you don't have the real experience. And a lot of people are only able to add portfolio projects. So those are what we consider weak resume, right? But you don't have a choice. You can only work on the, portfolio project. But then after she worked on 2 real projects, yeah, I think she got an offer, from the first interview she had, which was pretty lucky. But I think the project prepared her really well for the real interview. So I'm going to skip some of these slides, and yeah, so this is the last slide. I just, again, want to introduce the program again. This is a 6 months part-time program, so we can have a full-time job. It's roughly 10 hours per week of teaching, right, including labs. But then Monday, Tuesday, and Thursday evening, we also have office hours. So students can ask questions when they get stuck on things. Portfolio project is included. For this program, the real project is optional. So you'll need to pay extra for client project. And the reason why this is the case is because this is not a full-time boot camp. For all the full-time program we have, it's included. Real client project is not for everyone, especially when you have a full-time job. So some students will complete the program first, and then when they think they're ready to start job searching, they will get enrolled in the real client project while they're getting career support. But the one-on-one mentorship is always included in all of our programs. And in terms of what you will learn in semester 1, we start with data engineering foundational skills, move on to modern data stack, and then we cover Spark, AWS, ETL. And in term 2, we'll focus on Lakehouse. And after graduation, student will receive one-on-one mentorship and job support for 6 months. And for the student who opt into real client project, it usually start after 2 months. That's when the student has built up some foundational knowledge and started, working with AWS, and we'll start to assign students to projects.